Hi, I'm Mark Smith, and this is the final tutorial video in the 3D modeling series and how to 3D model using the Macropod Pro 3D. So I'm going to go ahead and jump right into this by opening the folder where our images were directed to go yesterday. Okay, so when your batch is completed focus stacking the individual directory folders that we created from the last tutorial video, you're going to receive a prompt in XeroStacker which will say batch execution is done. When you see that, you can press OK, close out as XeroStacker because we're no longer going to be using it. And the next thing you want to do is just open up your folder, go to the place where the images were directed. That was our final folder. And you just want to open these up to make sure that there was no overlap, that everything was correct. So we're just going to open these. And now we're just going to go through them just to make sure that the rotation is there. And you can see all of these images are now completely in focus. The rotational, or the rotation is right around 5 degrees from frame to frame all the way through. So here it looks like we do have a pretty good subset of data which we can plug into our 3D model. Now in some cases you do need a little bit more data than this, so one of the things you can do is just sort of reposition the pin and capture another set of photographs if you need to, but there's also ways around doing even that. So I will talk about those in other tutorial videos about Agisoft Photo Scan, but I will not, for the sake of time and speed, for this video series because it is kind of a long instructional series. The other thing I really want to show real quick is just how long it actually took to process these photographs. So I just want to show you yesterday this, actually it says last open 9/23. Let's see, so there should be a created date. So we'll just go to get info. And let's see, so created yesterday at 3:24 p.m. And what we're going to do is now we're just going to go to the last photo and then get info here. And this one was created at 6:22 p.m. So it looks like the whole process took about 3 hours to process all of this data. My guess is that that's because there was other work being done in the background. Typically, if XeroStacker is the only thing running on a computer with this level of specs, and I'll just show you real quick what the specs of this computer are, it would take about an hour to an hour and a half. But this is a good validation of just how long this specific project took. What I'd also like to show is what I'm using to process, because Agisoft Photo Scan really requires a lot of memory and high processing speeds. This computer, I'm using Mac OS Sierra. It's version 10.12.4, and the processor is a 3.5 gigahertz Intel Core i5. Memory is 32 gigabytes, and then the graphics card is AMD Radeon M9. So that'll give you an idea of the computer that I like to use. You can of course go more powerful, but again, you're not going to miss out if you have a computer that runs on less power. It's just going to be a longer process for you because the processing times are a bit longer. So I'm going to go ahead and jump right into how to do this. So first we're going to open Photo Scan. I have a Photo Scan Pro version, which is what I'm going to be using. They're not all that different. If you notice, I have this bright green screen in the background. I like to use green because it's an abnormal color based on the photo we just took. But you can change that if you go to Preferences, go to Appearance, and Background Color. I can select any color that I want. If I want white, it'll change to a white background and so forth. But I'll show you in a second why I like green. But first, what I'll do is just go ahead and start processing this data. So the first thing you want to do is create a new chunk. You can create multiple chunks using the same photos if you need more accurate results. But again, that's something that's a little bit more sophisticated in the program, and I'll walk you through that at a later time. What I'm going to be doing now is just adding the individual photographs to that chunk. So we're going to go to the Active 3D, Video Tutorial B, and Final, and we're going to select all of these images. We're going to open them. And now the images are going to be imported. You're going to see them over in your dialog box. I think a lot of times that box is down underneath. I prefer mine to be off to the right so I have a full screen in front of me. And now I'm going to walk you through the first step of this workflow. I personally don't mask these images. You can mask out the background to make it a little bit easier, like clean up a little bit easier, but for the sake of this demonstration, I'm not going to do that today. So what we're going to do is go to Workflow, that tab, and then you're going to go to Align Photos. Now, you always want to start with just sort of the predetermined standard settings, key point limit being 40,000, tie point limit being 4,000, and I do go at the highest level of accuracy to align photos. It takes longer, of course, and you're not going to have all that different results with using high. But for me, I really, quality is really important to me, so I'm just going to stick with the highest on just about everything that we do here. So I'm going to go ahead and press OK, and you'll have a dialog box come up, which will tell you that processing is in progress, and it's going to go through and perform a variety of different functions. It'll give you its progress, but this step, I warn you, does take a little bit of time. Even with a computer this much power, it could end up taking anywhere between 5 to 10 minutes. So what we're going to do is we're going to pause here, and then I'll come back and resume this tutorial once processing has completed. Okay, so the first part of this workflow is now complete. You can see that I have a dense, well, not necessarily a dense, but a small loose point cloud of my model, and you can see how well that came out. You can see that the pin is here, you can see the wings already, you can see the bee, and you can even see the stage at which the pin was mounted. So that's the first step, but one of the things I did mention earlier was the importance of the background color. So what we want to do is we want to clean this model up, and to do that sometimes there's pixels that would match the background. So in this case, what you might want to do is go back to Preferences and Appearance, and you just want to click on any color that would give you a high level of contrast. So we're going to go with green, and now you can see all these white pixels that are located around the sample. But for the most part, this is actually a really clean looking model. But what I'm going to do is I think I'm going to change that color because the white is still a little bit hard to see against the green. So let's try red. Press OK. There we go. So that's really high contrast. You can now see the loose ends where there is white. So now what we want to do is we want to clean up this model, and you can do this a variety of ways. But I'm going to start with the simplest. Which really is just to take, where is that? Take your tool, here it is. So this rectangle selection, or you can do freeform selection, which is the one I prefer. You just want to take your tool, and now you want to start to select. You want to hit the X to eliminate those pixels. Now, if you want to do it the other way, let's say you want to just select the pixels that represent your known specimen. One thing you can do is just draw around it, and I think we're going to leave the stage in here for this step. Keep drawing around it, go in and under with that loose white one, and then you can also crop. So what we're going to do is crop, and that's going to eliminate any other pixels. You can also rotate the model. You can see that here's some added pixels that we want to eliminate. So we're just going to go back to this. I'm going to select a few, X those, and so on and so on. And we're just going to continue to do this until there are no loose pixels in space. So I'm just going to speed this up for you now. Okay. So now we're back. I think that this is pretty clean for proceeding to the next step and phase of the workflow. One thing that I want to just point out real quick is that if you were to zoom out of this, and let's say you weren't confident on the alignment, this one came together really well. But let's say you weren't confident, you could check the alignment of the photos that we captured by clicking that camera function. So this shows where we captured each picture, and it'll set it up in the pattern at which we captured. And you can see here that these photos are perfectly aligned in a 360-degree sphere in approximately 5-degree intervals, which is exactly what we want when reconstructing a 3D model. So that's perfect. Next thing I want to do is, just because this red I know is a little bit harsh, I'm just going to take this back to a different color. So we're going to go back to appearance. I think we're going to set this back to white. Press OK. And there we go. So now we're ready to proceed to the next step in the workflow. So now what we want to do is we want to build a dense point cloud. You could go right to the mesh, but you're not going to get as clear of a 3D model or as accurate of a 3D model as is represented by the images. So what we're going to do is we're going to build a dense point cloud. Again, I'm sticking with ultra high. It takes longer. I mean, I could do medium, and this could be a very fast process, but I like to strive for quality, so we're going to go with ultra high. Depth filtering disabled. You just want to leave that. We can talk about what that function does in another video, but for now we'll just leave it as standard. So we're going to go ahead and press OK. And we're going to let this process and build a dense point cloud. Again, this process is going to take anywhere probably between 5 to 15 minutes. Alright, so I'm going to pause here and we will revisit once this step is finished. Okay, now the dense point cloud is finished. So we know that because the dialog box just went away. It's going to still continue to show the point cloud that we had prior to producing the dense cloud, but to turn on the dense cloud, you want to move up to the top and you want to click on the next icon over. And now that's going to recreate the dense point cloud of that specimen a bit more. And now what we want to do is go ahead and now we want to clean up this model. So one thing you can do is, if you decide you don't want this pin, you can cut out the pin, or you can just keep it depending on well, however you're going to display the model. I think for this we're going to keep the pin, but what I'm going to do now is go through using the same techniques as before, using this grab tool here, which is going to be freeform selection for me. Again, you can use either, but I'm just going to use freeform. I prefer it. I'm going to go ahead, speed up the video frame, and I'm going to start to clean up this model. Okay, so now that I've just gone through and I've cleaned up all this model, I've eliminated any points that are located, out in space, not what I think is going to be part of the bee. Now this bee has a lot of hair on it, and what we're going to do is actually keep a lot of the loose points around the bee there, just in case it can give us an accurate reconstruction of that hair as well. So once you're done cleaning up the dense point cloud, the next thing we want to do is go ahead and triangulate the mesh. So to do that, you're going to go back up to your workflow function and you're going to click Build Mesh. Once you do that, there's a few different surface types you can choose to use. Now, arbitrary is what you want to use when you're building a model like we're building now. Height field is when you're building a model of, let's say, a surface topography. So if you're producing a DEM, a digital elevation model of satellite imagery, that's better suited for height field because it's only going to reconstruct one orientation of the model. So because we're not using a planar surface, I mean in our case, because we're imaging small things or outcrops at geological field sites, things like that, that's a bit larger scale. You could use height field on outcrops because you're not necessarily going to be needing the information that's in the earth, but for small samples like this, you're going to want to use arbitrary. The other thing is, I did mention a leaf. Let's say you were reconstructing the topography of a leaf, and you wanted to look at where all the stomata were and also visualize that in a 3D way. Height field would be more appropriate if you're interested in only one side of the leaf. If you're interested in both sides, arbitrary is the one you want to use. So here we're going to have arbitrary, the source data. We can either do it from the sparse cloud, which doesn't make any sense because we've already produced a dense cloud. So we want to do it from the dense cloud. It's going to yield a more accurate model. We're going to have a face count. We want that to be as high as possible. Again, we're looking for top-notch quality. The interpolation, we have it on disabled. That basically means that if there's any data missing, any points missing anywhere along the structure in the dense point cloud, so for example, if I go down and I just kind of point out this area right here of the stage, there's missing information, there's a hole. So basically, if this is disabled, the software is not going to try to fill in that hole for us, which is what we want. We want that to be disabled because, again, we don't want the computer to predict what isn't there for us if it's not, one, if it's not a concern, and two, if it's going to if it's not going to not accurately represent the scientific information we're after. So again, that's going to be disabled, and from there, don't worry about point classes. We're just going to go through, press OK, and while this is processing, again, this is going to take some time. So we're going to let this run, and then we'll revisit it once the model has been produced. As it turns out, that didn't take very long at all. In fact, it took around 5 minutes or even less. So that means that we now have a completed model. So the way you would show it is go back up to the top taskbar. We're still selected on the dense point cloud, and click on shaded. That is going to apply some color to the model. The next one over is going to indicate where the triangles are in this mesh. And then the next one over is going to show basically the hollow points of the size of your triangles. It's important to say that this version of PhotoScan, the Pro version, can do really accurate volumetrics, measurements, and so forth on any specimen. And it's also important to bear in mind that we modeled this using 1x magnification just for the sake of time and ease of use and instruction. But again, if you were to do this same sample at 2x or even 3x magnification where everything's shown in context, it really is amazing how accurate this software is and has proven to be. It's been shown time and time again in scientific publications that this method of reconstruction is incredibly accurate, almost if not 100%. But now after you have this model, there is one thing that's left to do aside from saving it, which is to apply texture. So the next thing we can do is build texture, which is going to apply the original colors that we used initially, and this is where the advantages of the diffusers that we use is really going to show. So in this case, what we're going to do is just use the generic method, use an average blending mode, the texture size, keep it at 4096. Enabling color correction, I don't want that, and enable hole filling, that's a good thing to have because, again, we're just overlaying texture and we know that the colors, because of the photography, the way it was set up, is spot on. So we don't want the colors to change, and we don't mind if the holes in the model are filled. So we're going to go ahead, we're going to press OK, and again, we're going to let this process. This process, as you can see, is happening pretty quickly. So what we'll do is we'll just sit back and then just speed this time up for you, and then we'll resume where we left off. Okay, so that is now done rendering. What we're going to do is we're going to go ahead, go back to the model. Now we want to apply the texture, so we're going to click on this icon here, and now we have a finished 3D model. Now remember, we didn't enable hole filling, so there is a way that you can come back through and you can apply the texture file to the model in a way that the holes are filled. That's something you can try. Another thing I'm going to be doing, I mean, this is really an introductory video into how to generate a 3D model, so the steps involved. So what I'll do after this set of tutorials is show how to go about refining a model such as this one. So in addition to this, what you can do is you can actually create two different chunks and overlay them. You can also, well, produce many more vertices, so that basically it doesn't look as rough textured. You don't actually see the triangles in the model and so forth. But at least for where we are now, with something that's as small as this, something that's as tricky as this, and with something that was less magnification than most, and something that's as hairy as this be, you can see that the representation of this model is pretty good based on what we've had. So for virtual viewing, this is a pretty neat thing. But it's far from perfect, and the model can be made perfect. So stay tuned for more tutorial videos, and I'll show you exactly how to make a perfect model from the data or the technique that was described in these tutorial videos. Just want to say that the last thing to do is to export this model. So if you do want to export, you can export the model using a variety of different file types, as an object file, an STL. Object files will preserve color in certain viewers. It's one that we like. Autodesk files are pretty good, and so forth. So you have lots of export options and so forth, and the models are there for you to use however it is you wish. I hope you found this selection of tutorial videos helpful when it comes to 3D modeling. And if you had, like I said before, if you have any questions, please leave them in the comment section below, and I'll be happy to get back to you as soon as possible. Thank you so much for watching, and happy 3D modeling.